Okay, I'm going to
0 hour, 9 a.m.
Okay. Welcome, everybody, to Astronomy on Tap. Now, I know what you're thinking. Mark, why are you dressed up as the most recognizable telescope in the world? Of course, you all recognize this telescope. It's the Fast Radio Telescope in China. And as you can see, I'm clearly matching its metallic exterior and conical shape. But forget about that because it is Halloween version of Astronomy on Tap. So thank you all very much for coming out. And before we get too much further into the show, it is my extreme pleasure to introduce our new host for Astronomy on Tap, MC or Schrodinger's Goblin is what they're going by now. But please give me everyone a virtual welcome, claps in the chat for our new Astro on Tap host, Afra Ashraf. Welcome, Afra.
Hi everyone, it's Schrodinger's Goblin.
A name for the ages, to be sure.
Really, my costume is exactly that, really.
Great. And you look exactly like how I imagine Schrodinger's Goblin looks. Fantastic. Well, I guess I don't know. It's welcome to the show, everybody. Let me jump back to Afra. Can you go back to sharing those slides real quick again, because that'll be a good way for us to introduce the show. Also, is my sound kind of weird in this cone of a costume? No? Okay, great. So, Afra, once you get those slides back up, I see some nice comments already coming from folks from the Blue Shift group at Columbia, which is great. So welcome everybody to Astronomy on Tap, Scary Science. We are, again, Astronomy on Tap. We haven't been around for a couple of months now, but we're very excited to come back to presenting fun, informal astronomy talks, preferably at a bar. But when we're not at a bar, we're at home drinking instead, if you wish to. Afra, do you have a drink tonight?
I certainly do.
Nice. I'm drinking Sweet Point 6 Action. Do you have something tasteful?
Blood orange cider.
Oh, yum. This cone is not only hard to manage the show in, but it's also hard to drink in, I'm realizing. So why don't you talk through the host and the presenter slides, if you will?
Sure. Okay, let's present. So here we are. We're the hosts, Mark, the infrared riding hood, and me, Schrodinger's Goblin, of course. But enough about us. I want to introduce our amazing presenters. Gabby Suissa from the University of Washington. She will be talking about the spooky science of other worlds. So super excited for that. And Marisa Murillo from Columbia University will be talking about the instrument Chaz, aka Chazbird, the friendly ghost, who apparently explores the CGM. So excited to hear about both of those. And if you haven't already, I hope you will click this link to submit some science-themed Halloween costumes.
Yes, we've put the link in the chat, so I know you can't click on this presentation, but
right, of course. And I hope you guys are in costume right now, science-themed or not.
Yeah. So again, this is a chance for you to show off your amazing costumes. It's Halloween time. We will be picking out the ones that we like and giving them a shout out and potentially sending them some prizes later on. So definitely, if you have a really cool costume from the last couple of years or even that you're wearing right now, please go ahead and submit them at this form here.
And even if it's vaguely science themed, please send it in. We would love to see it. And again, prizes. You might get a trick, you might get a treat, you might get both. So, might as well enter.
Afra's in charge of the tricks. I just do the treats.
That's right.
Cool. So besides this opportunity to show off your cool costumes, we also have some Astro costumes for our game tonight. I spent this afternoon putting some classic Hubble images into Halloween costumes. And so your job is to figure out who's underneath each of these masks. Again, the link is in the chats for both the Facebook and the YouTube stream. And you can play along here at that link. And so, again, you might be able to recognize some of these things. Maybe you recognize the costumes. Maybe you recognize the cosmic objects. We'll find out who can figure out which is which by the end. So just submit them through to that link. It'll do all the scoring for us. We'll come back to that again halfway through and show off who wins at the end.
Yeah.
Yes. Go ahead.
Oh, just wanted to point out some of these questions, which you'll see if you play at the quiz. If you like minions, they're here.
And I have to say that the last couple of questions, I was not running out of time, but they're a little more direct. Cool. So we're almost ready to have our first speaker ready to present. But before we do that, the last couple of slides here, we just want to shout out. What are the last couple of slides?
Oh, yeah. We want to shout out Startorialist.
Our friends at Startorialist, one of the founders of Astronomy on Tap in New York City, DJ Carly Sagan.
Otherwise known as Emily Rice.
Well, no, that's unconfirmed. They're different people.
Right.
We've never seen them at the same place. I think they're
Right.
nemesis. Anyway,
probably.
It is Halloween season, and so if you want that nice little touch of a little astronomical addition to your costume, or just want really cool astro-themed clothing and accessories, definitely check out Startorialist. We're not paid to plug them. We just really like their products.
And it says here you can actually buy the universe, so I would take that deal.
The whole universe for sale. Amazing.
Wow.
Well, we're not going to have the whole universe in this but Afra, why don't you go ahead and introduce our next speaker?
Yes.
Our first speaker, even, of the night.
Our very first speaker. So here, I will stop sharing. So
no, it's okay. We're good.
Is that a problem? Oh, okay. So Gabriella Suissa, goes by Gabby, is a graduate student at the University of Washington. She's studying exoplanets and astrobiology. She was raised in Philly, went to college in New York, worked at NASA, and just recently moved to Seattle to continue her PhD. Gabby spends her days thinking about life on other planets while always remembering that Earth is her favorite planet. And we are going to put her Twitter on her bio so you could follow along with her work.
Let's all give a huge round of applause to Gabby.
Hello. Hi, everyone. Thanks so much for having me.
And here are your slides even.
Perfect. Wow. Okay. So am I good to go?
Please, take it
You're
away.
set.
Okay.
Yeah.
All right. Well, thank you so much to Astro on Tap for coming back from the dead and inviting me to their first resurrection party. Like was said, I'm Gabby Suissa. I'm so excited to talk to you guys today about exoplanets, the spooky science of other worlds. This is my first Astro on Tap talk, so I'm going to do my best to be funny and be relatable, but let's see how I do. So exoplanets, like I said, I think they're super cool, but hopefully maybe today I'll convince you that as well, and that maybe they're a little spooky too. So the cool thing about exoplanets is that there are planets that are outside our solar system around different stars. So right here, I have a picture of the pumpkin sun, which is actually a photo of our sun in the ultraviolet, which is super cool. It looks super creepy. But if you can think about it, our sun has 8 planets and a whole like beautiful moons, beautiful asteroids, comets. That's all in our solar system. But if you go far away to other stars, around other stars in our galaxy, there are planets around those stars, and those are called exoplanets. And that's just mind-blowing to know that almost on average, every star you see in the sky, every star out there has on average 1 planet orbiting it. And that's so crazy because then just like we already see so many crazy planets in our solar system, just thinking about all the planets that are out there, exoplanets. And so here we have our pumpkin sun, and we have a little planet that's trapped, orbiting around it. Help me! Oh no! And we have our evil little star. So this is what happens, not really, but this is what happens on other systems. Planets orbit other stars. So how do we even find these exoplanets? Like, this is what's crazy. They're so far away. We actually don't look at them directly. We look at the stars that they orbit. So here's a video, like an animation of a faraway star and a planet passing by in front of it. And this will come around again, so I'll give you guys a chance to see it again. But when the planet passes in front of the star, it has a shadow, and that blocks part of the star's light. And so we're going to see this right here. On the left, there's a graph that shows how bright the star is. And then when the planet crosses it, there's this huge dip in brightness. And so because of that shadow, we see a planet, the signs of a planet. We're not imaging the planet directly. We can tell that it's there, though, because we see that something passed in front of the star. This is called a light curve on the bottom left. That is that shape right there. That's a light curve. And, you know, it's oddly similar to, I don't know, a ghost? I don't know. But really, actually, planets are out there hiding in the shadows of their stars. So they're kind of ghost-like in that sense. And it's kind of ghost-like in the sense that you see in movies, you can tell there's a ghost there. You can't really see them. You can just see the effects of them. That's what it's kind of like for people, you know, hunting for exoplanets. We are trying to find the signatures of exoplanets when we can't really actually see them with our eyes. This is me trying too hard to convince everyone that exoplanets are on theme for Halloween, but here's my thesis.
You flip that graph around and it looks like a ghost now. I think you nailed it.
Thank you. In this essay, I will prove.
Guys, I think everyone who has a drink in their hand should take a drink whenever you're scared by Gabby's talk.
Absolutely. Oh my God, it's terrifying.
Afra before this event was like, how many drinking games do you guys have about your talks? So, yes, if you're scared at this science-themed bar event, please take a drink.
Absolutely. Or if I make a joke and you cringe at it, take a drink. That's great. That's great too. Let's keep going. So actually, there are these spacecraft missions in space right now, staring at stars and seeing if their brightness dims for a bit. And that will tell them that planets are there. So one of the biggest planet hunters that's alive right now, alive in the sense that it's functioning, is called TESS. So TESS is a planet hunter. TESS stares at stars, sees if the brightness of those stars dim, and determines whether or not there are planets orbiting those stars. I love TESS so much. It's like the ultimate Ghostbuster because it's looking for these planet shadows. And, you know, when it's Halloween, I personally want to dress up as Ariana Grande because thank you, Tess. Thank you, Tess. Thank you, Tess. I'm so fucking grateful for my exoplanets.
Wow.
Because Tess finds our exoplanets. So thank you, Tess.
Nailed it.
Thank you, Tess.
So we actually have around 4,000, over 4,000 confirmed exoplanets. And some of them are just wild, like literally out of this world, but like also like crazy. And actually NASA has released fun Halloween themed posters that you can download on their website for free. So this is an example of a planet that is experiencing flares of fury from an angry star. So not all stars are like our sun. Some stars are super more, volatile and have lots of flares and are just super angry. And so some planets are subjected to that horrifying fate. And this is a poster showing AoT, which is one of those planets. We also have zombie worlds, which are planets that are actually orbiting pulsars, which are stars that are basically dying. They're dead. They exploded and there's just a leftover remnant. So it's kind of like an undead zombie star. And they're subjecting their planets to extreme radiation. So if you're interested in these posters of like really cool extreme worlds, those are totally available to download on NASA's website. You just have to look up like NASA Halloween posters.
In fact, I just put the link in the comments.
Awesome. Thanks so much, Mark. And there's also travel posters from NASA, which are really great, just to emphasize like how wildly different these planets can be. This one is a lava hellish planet. Oh my God, that is so scary. But actually, this kind of planet is literally an ocean of lava because it is so close to its star and experiences such extreme temperatures. There's also even scarily dark, perpetually dark planets. There's planets with no stars. I like to call them orphan planets because they've been ejected from their systems and they actually don't experience like any light shining onto them. So they're perpetually dark. So there's lots of scary, spooky, creepy planets out there. And here's a fun animation. And again, these are just animations. We don't have pictures of them, of just kind of the variety of what kind of worlds could be out there. We can have ice worlds, worlds with oceans underneath, lava worlds, like I said, and worlds that maybe, perhaps, maybe, kind of remind us of Earth. Now, Earth-like is a really scary word, extremely scary word for planetary scientists and astrobiologists, because when people say, "Oh my God, we found an Earth-like planet," that's a whole lot there to unpack. So I just want to clarify. Earth is unique. No planet is really going to be like Earth. When people say that they're searching for Earth-like planets, really what they mean is they're looking for Earth-sized planets because those are small. And because they're small, they're probably rocky. So there's a surface to stand on. Jupiter is like not really life-friendly environment. So Earth is terrestrial. It's a land planet. And they're looking for planets in the habitable zone, which is, again, another scary word in the sense of what it implicates. But the habitable zone literally just means that it's in the right temperature in regards to its star, that it's not too close and not too far, that you could have liquid water on its surface. Big emphasis on could. Doesn't mean you will, but it just means it's not that hot that it will boil off and not that cold that it will freeze over. So when people, you see all this hype, they're looking for Earth-like planets. Oh my God, we discovered Earth-like planets. We really don't know what these worlds are like. We're just looking for planets that are small, rocky, and in the habitable zone, they might have water. And we actually found Tessa's first habitable zone planet. I was part of the discovery team and I got to characterize it, which is super exciting. This is called TOI 700D. It's a planet in the habitable zone of an M star. An M star is an angry, redder version of our sun. And so on the right, you can see the light curve, the upside down ghost. That shows us that that planet is there. So we can tell from the light curve the size of the planet, and maybe we can even tell if it's rocky or not. But we really don't know what its atmosphere is like. We're really only seeing shadows of these planets. And this is where the really hard part comes in. And this is something that I love to do for my work. I use atmospheric models to try to guess, what are these planets like? Like what are these worlds like? One thing that's crazy about this kind of world is that it actually spins really differently than our Earth. Here's an example of the Earth, and you can see it's bathed in sunlight, but it rotates so that, we all get our fair share of sunlight. North America has daytime, and it's nighttime on the other side of the planet. And then it rotates. We all get our fair share. But a planet like TOI 700D is actually stuck with only one side perpetually bathed in sunlight and the other side perpetually perpetually in the darkness. So this is really like a completely different world. So even though this planet is the size of Earth and is in the habitable zone, we already know that it's going to be so different no matter what it's like, because you can't nap on one side. Like literally, it's just not the same. Well, I can nap because I can nap in any kind of level of daylight or nighttime, whatever. But this is a totally different world than what we're used to.
I like how we're being presented with this mind-blowing, like tidal locking, never having a nighttime, and your first thought is, what about the naps? What about the naps?
What are you gonna do?
Who cares about growing plants or like days, circadian rhythms or anything? What about the naps?
Exactly. So this kind of planet is really interesting. And, we want to know, like, I don't know, what is this going to be like, the atmosphere of this planet? And I want to first off say, we do not know. We don't know. We took models to try to find out. We modeled 20 different possibilities. Like, oh my God, what would this planet look like if it was covered in ocean or land, or if it had an atmosphere like our Earth, or our atmosphere like the early Earth, like 2.7 billion years ago, or the atmosphere of Mars? Or what if it was like different atmospheric pressures? Like, what if it felt like the surface felt like you were on top of a mountain, like really low pressures, or deep below the ocean, like really high pressures? Like, all these possibilities are possibilities. And so we modeled them to see what this kind of planet would look like if it had this atmosphere. So here's an example. This is like a simulation. The colors mean temperature. So this is a land-covered modern Earth. So imagine the Earth with no ocean. This is, what if that planet that we found, TOI 700d, what if it was a modern Earth covered with land? You can see one side is really hot and the other side is really cold, because the one side that's red is the hot side. That's the side that's perpetually bathed in sunlight. And the other side is dark purple because it literally just doesn't get any sun and it's really cold. And the little squiggles that you see on the upper right are called spectral signals. They're like basically saying, like, how could we tell what this atmosphere is if we sent a special instrument called a spectrograph to look at it? So, for example, it says, oh my God, there's a CO2 line or a methane line. That will tell us that there's CO2 and methane in this atmosphere.
Gabby, sorry to interrupt.
No, go for it.
Did you mention if what size this planet is? I know you said it's in the habitable zone.
Yeah. Thank you so much for asking and having me clarify. It is 1.2 times the size of the Earth. So in terms of like 1.2 does not equal 1, but for astronomers, it's like, hey, it's basically 1.
I mean, sometimes I have 1.2 servings of ice cream, and that's basically 1 too.
And you should be able to do that. Yeah, absolutely. Yeah. So this is an example of like a potential climate that we modeled. We don't know if this planet is a land-covered modern Earth. We figured out if it was one, this is what it would look like. And the cool thing is that it's in other simulations that we did, like this crazy one where you can see it's red everywhere, which means it's super hot everywhere. And the reason why this one's hot is because it has an ocean. And so the ocean actually circulates heat from the night side to the day side. So even though one side is dark, it's still super hot. So even in this example, though, the ocean stays, which is super great for people worried about, is this planet going to be a reliable planet that has water? In our simulations, in these two simulations that I showed you and the other ones that we have, it still keeps the water. The planet still keeps the water in the simulation. Because sometimes if, again, the planet's too hot, the water can evaporate. So even in this really hot atmosphere, the water stays, which is super exciting. To just know, like, hey, this planet is in the habitable zone. It seems pretty good at keeping water on its surface. So we model these planets, but we really have to ask, like, are planets like this planet, TOI 700d, are they habitable? Like, what does that even mean? Yeah, I did the spooky habitable.
Oh, I see.
Yes, this is very intentional. Well, the thing is like, habitability is a really scary word. Like, let's say TOI 700d, let's say it has an ocean. Let's say we found out to figure out a way that it has an ocean. Does that even mean that it's habitable? No. Like, there's so many other factors that this is a scary chart, spooky chart that shows all the scary things that go into considering habitability. For example, our Earth has plate tectonics. We recycle material. Plates go in and plates separate with earthquakes, and stuff comes out through volcanoes. That's actually really important for habitability, for life on this planet. Another example is our sun is pretty mild. It's not an angry star. If you have a star that's too angry, it's going to throw a lot of radiation at you. And our planet has a magnetic field, which protects us from radiation. Not all planets have that. So there's so many different things. Like, it doesn't mean like, oh, I'm a planet, I have an ocean, therefore I have life. It is not like that at all. And I'm part of the UW, University of Washington astrobiology program. And so that kind of program really tries to answer these questions like, what does it mean for a planet to be habitable? What do you have to consider? And will you ever find like a sign of life, for example? And this is called biosignatures. Again, woo, biosignatures. Biosignatures are basically signs of life. It sounds simple, but it's really, really hard. Like, how do you see if you find an exoplanet, let's say you find that it's habitable somehow, you find that there's an ocean and it seems like the perfect conditions for life to exist, are there signs that life is existing there? In our planet, oxygen is a biosignature because we know that, because it's from plants. Plants are life. Plants produce oxygen. That's awesome. We have a biosignature. But there are other planets where they could have oxygen, and that doesn't even mean that there are plants there. It could mean anything. And so this is the really scary science of figuring out biosignatures. Like, if we find a planet that seems to have the right conditions of life, are there any signs of it that it has life there? How do we know for sure? How do we know it has life now? What if it had life in the past and it died out? What if even you had a perfect planet that's exactly like Earth? There still doesn't mean there's life there. Like, does life succeed everywhere where there are perfect conditions? We don't know. These are scary, scary questions. Woo, signs of life. We don't know. Yeah, and I guess like the spookiest thing ever is just like an alien, obviously, like that's scary. Although I really encourage you to think of it more microbes. That's how I like to think. You know, when you hear astrobiology, like I don't want you guys to really be thinking about, you know, the green people, although we don't know, for all we know, it could be. But what really I like to think about is bacteria, because at least in our Earth, that's the first type of life that existed. For 4 billion years, we had microbes. So it's not unreasonable to assume or think or at least hope for that the other life that we find might be simple life. Although, again, we don't know. And again, we have all these exoplanets. We have 4,000 of them so far. We're still finding more. We don't know what they're like. We're trying to ask these questions. What are their atmospheres like? What are their surfaces like? We just don't know. And honestly, to me, nothing is scarier than the unknown. So hopefully I convinced you that exoplanets and the field of astrobiology and finding life is scary. And if not, I hope at least that I convinced you that it is cool. And I'm done.
Yay.
Yay!
Although I think you do have to say that last slide in the voice for the spooky text.
Nothing is scarier than the unknown.
Amazing.
Ooh.
Amazing.
That was amazing.
Fantastic.
Thank you so much.
We are going to ask you a few questions, but as we're asking you those questions, folks, please, either in Facebook or on YouTube, use the comment section, ask some questions in the chat, and we'll be able to field them as we go. For example, somebody posted in the chat that they love the spooky habitable voice, and so that's why we made sure to do it right here at the end as well. Cool. Afra, do you have any quick questions you want to ask Gabby?
Yeah, well, for one, Gabby, I am in awe and also scared a little bit. I would love to hear more about astrobiology. I'm sure a lot of people in the chat have never heard of this interesting interdisciplinary field that you are studying so in depth. And I'd love to hear your 5-second pitch on what is astrobiology.
Thanks so much for asking. So astrobiology is basically just the study of life in the universe. We are on a beautiful planet that is like teeming with life, and we're so lucky for that. But are we the only ones? That question is like loaded, and that's a question that people for centuries have always asked. Like, are we the only ones? Are we alone in our little planet? But the thing is you need multiple fields of science to study that question. You need biologists who understand how life here works to answer that question. You need astronomers who understand how to look at faraway exoplanets to, help understand that question. You need geologists who know how to study fossils and look at the fossil record and look at I don't know, what if there's dead life on Mars? We don't know. I'm not saying there is, but who knows? You need experts in those scenarios. You need people who are good at studying the genome to see like, how does DNA work? Like just so much. It's really just like trying to boil down our existence into a field and just seeing like, can it be replicated elsewhere? Like it's an overwhelming kind of field because it just literally has so many questions. And so, like you said, it's really interdisciplinary. It's people from all types of science really trying to understand this question. And it's a lot of collaboration. No one person has the answers. I mean, obviously, but no one person can do it all. It's a really collaborative, like every day as an astrobiologist, I work with people outside my field, and that's awesome and healthy for like a good collaboration because none of us know the answer, and we're all trying to pick away at like maybe what could be out there. And the really exciting part is right now, a lot of it's theoretical, but soon we're going to have space telescopes that really can look at these exoplanets and tell us what's in their atmospheres. They could be like, hey, this planet has oxygen. And then we can all sit down and be like, what does that mean? So that's super exciting.
In fact, it's so exciting that Amber Young here is asking, amazing talk. How excited are you about the prospects of James Webb? So first of all, you're going to have to explain what James Webb is for the audience, or future missions to maybe answer those questions, uncovering those unknowns.
Thanks so much for your question, Amber. So for those who don't know, James Webb is a telescope that's set to launch soon. That is kind of the successor of the Hubble Space Telescope. So anytime you've seen beautiful images of space, of galaxies, it's most likely taken from the Hubble.
Like those in our game, for example?
Exactly. Except without the costumes. But yes, yes. So James Webb is the next one. And that's really exciting for anyone in astronomy because this is new technology that we can use to just look at anything. And like looking at exoplanets. And so Amber's question is, am I excited for James Webb? Yeah, definitely. Like James Webb launching, absolutely gonna help us like learn what these exoplanets are. There's so much variety of exoplanets. There's exoplanets that are as big as Jupiter, but close into their star like Mercury, which is really weird. So like James Webb will be great at finding out about those kind of planets. I think for habitable planets, as in planets in the habitable zone, they're so small that I'm not sure how successful James Webb will be to really characterize, like, does this atmosphere have oxygen, for example? But the nice thing is it'll give us the groundwork for the next space telescope to tell us. So the decadal, which is every 10 years, the astronomy community is like, which telescope should we launch? And they're going to announce their answer to that question soon. So we'll see what's like the next telescope. So I think by then, hopefully we'll get some really exciting answers.
Cool. We're running, we got to keep moving, but there is time for one more question. If you could actually go back to the slide that you're showing with the shadow of the planet, which I believe is also known as the transit method. We have a few questions about it. So here, Emmett's asking, for the orphan planet, how do you find them if they don't cast a shadow? And a similar question from somebody who I believe you know, Gabby, because they share a similar name to you. Are there other ways at all to model the planets besides the shadow technique? If not, will we ever be able to develop technology to directly image them?
Wow, okay, these are great questions. So there are other methods to find planets besides the shadow technique. Some of them are really difficult, but most of them involve a star. So I'm actually now panicking in the moment because I realize this very scary thought, like, how did they find that orphan planet? I don't know. I'm going to have to check this out. I'm like, my whole life is flashing before my eyes.
Is it gravitational lens or the lensing?
I think it's microlensing.
It's microlensing.
Wow. Right? Okay. Yeah. So microlensing is this technique that like 1% of planets are used to find. It's just like, but yeah. Okay. So I'm guessing
if you don't want to explain what microlensing is in 30 seconds, you don't have to. But perhaps we could encourage them, give them some Googleable words to search for.
Yes, definitely. Microlensing, we can use the bending of space-time of massive objects, and you can be able to see like, oh my God, there's a planet. So there are other methods besides the transit method, which is super exciting. We can tell the tug between a star and their planet, like their tug of war kind of thing going on instead of the shadows. But transit method is definitely the most popular. We'll see for the future, but that's what's working for now.
Cool. Well, that's all we have the time for Gabby's talk right now. Let's all in the chat, please give another round of applause for Gabby. There's some wonderful comments in there as well.
Oh, thank you all so much. Thanks.
So thank you so much for speaking.
Thank you, Gabby. That was amazing.
Okay, goodbye.
Bye.
And so we're just going to quickly, before we move on to our final speaker of the evening, plug our game one more time. I've already got about 10 responses at this point, which is great considering that it's telling us there's only about 12 concurrent viewers right at this moment. So we appreciate that. But just to plug it again, Afra, can you bring up those slides?
Yes.
One more time, and we'll put the link again one more time. This is the other opportunity you have to win a prize, either by submitting a costume, a science-themed, quote-unquote science-themed costume to us, or also completing this game, which we're going to try and show you. I don't see it backstage. So maybe we're not going to show it to you. Maybe we'll just...
You don't see it?
I do not see it backstage. So, you know what? Forget about it. Just we'll post the link again. All the pictures are there. So you can just go from there if you want to. Maybe then, Afra, instead, you can begin to introduce our next speaker. How about that?
Yeah. I'll go ahead and introduce our next speaker. So our next speaker is Marisa Murillo. And she just finished her bachelor's degree in mechanical engineering at Columbia, where she worked with the Schminovich Astrophysical Instrumentation Lab. She worked with the team on CHAS, the circumgalactic H-alpha spectrograph, to observe the circumgalactic medium in nearby galaxies. I am sure these are a lot of words some of you may not have heard before, but I am super excited on my end to hear who is CHAS. Is he friendly? Is he scary? What kind of ghost he is? And Mari will take you through all of that, I'm sure.
Give it up for Mari.
All right, hi. Am I on now, Mari?
You are on stage.
You're on.
Okay, perfect. Yeah. Anyway, like it says here, hi, I'm Mari, and I'm so excited to be at Astronomy on Tap. Thank you all so much for having me tonight. So today we're going to learn about Jasper the Friendly Ghost.
We don't see your slides right now. Sorry, Mari. You have to share your slides with me, please.
Oh, okay. Give me.
So while you're doing that, I will just plug the
Sorry,
game.
I thought I shared it.
No worries.
Share screen. Share screen. Tab. Okay. Yeah, so sorry, I thought I shared that. Oops. Okay.
There we go.
Okay, we're good now. Okay. Yeah, so today we're going to learn about Jasper the Friendly Ghost and his mission to explore the CGM. I spent way longer than I care to admit photoshopping this promo image, so please appreciate it with me.
Hey, solidarity. I spent way too long making the game.
Absolutely, thank you. So CHAS is the instrument that my lab group and I have been working on, and we call him CHAS, but his government name is the Circumgalactic Hydrogen Alpha Spectrograph. Thank God for nicknames. So a good first question to ask here is, what is the CGM? This is the CGM. CGM stands for Circumgalactic Medium. We're studying the diffuse gas around galaxies. It's a crucial missing component in our understanding of the universe. And by studying the CGM, we can learn more about galactic formation and evolution and more fun and exciting big questions of the universe. Ooh, spooky. Yeah. So here's a little bit about how CHAS works. Here's a picture of me working on CHAS and a pixelated version on the right. And I think Chaz is the most exciting thing in the world, and I absolutely hope you do too. So it's an instrument called a spectrograph that attaches to a big boy telescope down in Arizona. And it takes the image from the telescope, kind of like we have on the left, and it pixelates it and turns it into something like the image that we have on the right. Except that with Chaz, the pixels are actually hexagons and not squares like you see here. So really, it's more like this. Yeah. So yeah, Chaz takes the image from the telescope and pixelates it. And for every pixel we have, we generate an emission spectrum. So once we have all these spectra, we can take a step back and look at the big picture. And essentially what we see is every individual part of the galaxy and what it's made of. I think that's so exciting. And quick disclaimer about me. I, of course, like Afra said, didn't actually major in astrophysics. I studied mechanical engineering. This is a common misconception about me. My own mother thought I was an astrophysics major for like 2 years. It's okay though, because my skills came in handy in this instrumentation lab where a great deal of what we do is design and construct our own unique instruments like Chaz. This is me working in the lab. I've been working here since the summer after my sophomore year of college, and I love it. It's so much fun, and I've learned so much. And as I've learned, you can never be too safe. Look at me, double goggles, as we all should.
Can you say just quickly, where is the lab located?
Oh yeah, it's at Columbia University in Pupin, that building where the first atom was split back in the day. I think that's kind of a spooky fun fact in and of itself. Yeah, it's here in New York City, in Pupin at Columbia.
Cool.
And this is my PI, David Schminovich. He's super cool. I love him very much. He is very kind, very wise, and also, as you can see here, super, super fun. This is the rest of the lab group, and I just think we're so cute. And this is a picture of Chaz to get you an idea of the general scale of the instrument. This is only a piece of it. When it's all fully assembled, it's about the size of a Formula One race car. But again, this is like pretty much the bulk of it, like a good piece of the body of Chaz to show you how big it's going to be when you got the full thing. And this is the Things survey. I gotta love this satanic death spiral of a data visualization. It's probably the spookiest thing we're going to see here today. And Things is a survey of nearby galaxies in H1. And there are quite a few equations describing H1's relationship to H alpha concentrations as derived with some sort of really scary calculus from the 1800s. And this relationship is important because, as you might remember, Chaz is looking at nearby galaxies in H alpha.
Sorry, Mark.
Yes.
H is hydrogen.
Yes, H is hydrogen. Hydrogen alpha is what we're looking at. And then this is like another sort of little alter ego hydrogen has called H1.
And we think hydrogen is everywhere, right?
Absolutely, Mark.
Okay. So these galaxies, lots of hydrogen. They should be bright, right? So they're spooky,
Totally.
yes, because you've colored them red here.
Totally.
And I'm getting a lot of like Sauron vibes, and like
So
I'm tempted to put on the
Lord
One Ring. But again, these are like we should expect them to be bright in hydrogen, right?
Absolutely, yes,
Okay.
That's so correct. So the relationship is important, of course, because it's between H1, which we see here in Things, and H alpha, which is what we are projecting to look at with Chaz. So I found a bunch of galaxies from the Things survey in a 10 by 10 arc minute sort of like field of view to complement what we're able to capture in one little snapshot from Chaz. It's the size of the field of view that Chaz has. And of course, they're going to be visible from the telescope where Chaz is mounted in Arizona, just to give us some targets for observation, so that when I do my simulations from this survey, they're galaxies that we were actually able to look at with CHAZ. So I select my targets, and I code, and I code some more. And then I end up with something that looks a little bit like this.
A double hack. Amazing.
Yeah. So this is one of many GIFs that I made from data cubes that I got from Things Survey. And this one is my favorite. It's NGC 628, which is a nearby galaxy that's like really sort of a nice like face-on view of a really beautiful spiral galaxy. And each frame of this GIF that you're seeing is a different velocity channel. That is, every frame highlights a different concentration of matter moving at one specific velocity. The lighter gray is going to equal a higher concentration, and the darker gray is going to indicate a lower concentration. So as you can see here, it's kind of like we're slicing through the galaxy by velocity and then sort of like putting it all together here in a GIF. And then what I did with this information was I stacked the frames for each galaxy together in sort of like a summation image using a lot of like calculus here that wasn't so fun. I did some calculations to sort of find the expected concentrations of H alpha and what those profiles might look like based on what we see in H1 from things. And this is what we end up with. These are my galaxies. These are my babies. I love them very much. I plotted them here in this color bar because I thought it was pretty. There's so many color bars you can use in Python. Side note, shout out to Gabby for showing me so many things you can do with Python, including what I think is the hardest part, which is choosing what color bar you're going to represent your data in. But yeah, these are a bunch of
Gabby, take a bow. Take a bow.
Gabby, yes, take a bow. Thank you.
Okay, bye, Gabby.
Yeah. So again, for each pixel, we get an emission spectrum that'll tell us how much H alpha is in every part of the galaxy. And these are the predictions of what we're going to see when we observe the same galaxies with CHAZ. So the next task is actually to compare these simulations with what we actually find. And the comparison will help us evaluate how effective the projected relationship between H1 and H alpha actually is for the CGM of nearby galaxies. And the best thing about working in an astrophysical instrumentation lab is that I get to do a little bit of everything. I'm literally Hannah Montana. This is the best of both worlds. Oh my God, here's a little hardware montage. I am so excited about this. So on the right here, okay, on the left is just me like drilling something like a little bit nondescript, but on the right, it's an instrument that we constructed to essentially like test CHAZ, the main instrument that we're building. This is a little like side instrument. It's basically a glorified refrigerator, except we like flipped the directionality of it to make it a heater instead of a refrigerator. Kind of different, but that's what we did. And we had to be super thorough with CHAZ just because it's like such a precise optical instrument. And we had to test these like environmental variables like thermal expansion, which it would see a lot of at the top of a mountain in Arizona. There would be a lot of like temperature change that this instrument would see. So we would have to test it to see how the optics would fare under different temperature conditions here. And yeah, I mean, it's all really fun. It's a lot of screwing and unscrewing and building and designing and prototyping and redoing. But yeah, I mean, getting to work with your hands and doing things super, super fun.
So I have a question. These
Yes.
you said this thing's going to be the size of a car when it's fully
Yes.
assembled. How are you testing the temperature for all these components all at once, or are you doing it bit by bit? how much do you care about some of the components? Like, do some of them just not care about the temperature?
Yeah, that's a great question. So what's going to matter the most is the optical parts of the instrument, which is mainly consistent of the optic relay. It's a series of mirrors and lenses that are all inside this box that I'm kind of leaning against here. That's mainly what we're testing because that's where, again, like the optics of the instrument are going to go through. So it's about the size of like that table that we're testing the thermal expansion on. It's a good question though. Yeah, so sometimes I get to wear a bunny suit and go and clean the clean room or work on optics or, just sort of do other things where I have to be all like suited up and protected so I don't damage any really sensitive optical equipment. And in the middle here is me with this plate tube mount thing that I designed for the camera, which is a really important component on our instrument. It's how we get our images out of the telescope. Again, super important. It involves a lot of SolidWorks and manufacturing. And then on the right is me taking a selfie in the grating of MicroChaz, which is a small portable version of our instrument that is made of commercially available parts. And its purpose is to be almost mass produced and distributed to educational institutions like universities and high schools to show the kinds of things that Chaz can do for educational outreach.
MicroChaz.
Yeah, I think
So
MicroChaz
cute.
is the cutest thing ever. Here's a little SolidWorks drawing that I did of MicroChaz. This is a little bit older, but yeah. I'm also designed an adjustable enclosure that is unfortunately not pictured here. I swear I have it, I just couldn't find the pictures, but think origami, but made out of aluminum sheets instead of paper that goes around these internal optical components here and just seals them up from any and all light that can leak through, and that's basically what it is. But yeah, it's just a mini version of Chaz, again, commercially available parts, just so everyone can have a little bit of the fun that comes with Chaz observations. So yeah, sometimes you break things, usually it's okay. In the process of machining hardware and soldering things, I do make mistakes now and then, and this is an example of one such mistake. I was trying to heat shrink wrap around these wires after I'd soldered them, and it was going so well, and then I melted the casing that goes around the wires. But in any case, I do love working in an instrumentation lab because I get to do all of the fun parts of the mechanical engineering major. And I get to see all my friends in the machine shop and feel really cool when I go into mill my little powder-coated aluminum X-beams for a top secret, super cutting-edge astrophysical instrument. It feels really cool and really exciting. And there are moments like this that make all of the hard work so, so worth it. And this is probably the most exciting thing that's ever happened to me. I know there might be some of you who are married and have kids, might have another idea of what the best day of your life might be, but as a young, single, chaotic mess of a person with absolutely no prospects of starting a family, just let me have this moment. Yeah. So here's Chaz, mounted on the 2.4 meter telescope at NDM Observatory in Kitt Peak, Arizona. And that's a really big telescope. It's that sort of gray, white, big cylinder at the very tippity top of that photo there. You can only see like a little bit of it. And Chaz is also a massive piece of hardware and super delicate as well. It's so massive and delicate that my PI and our team of grad students actually had to drive Chaz in a van all the way from New York City to the middle of nowhere, Arizona. Like, what a trip that must have been. This piece of metal and glass got seating priority, leaving everybody else kind of squished against the window all the way, again, from New York City to Arizona. What a trip. Anyway, here's a photo of me preparing my very first research poster ever. This is kind of also what it looked like when I was making slideshow. Kind of looks like I do anything because I don't really know what I'm doing and I'm a little bit of a procrastinator, but that's all right, really. And here I am presenting the same information here at my first conference. The conference was actually in Hawaii, which is so much fun because it was basically a science-themed vacation with all of my friends. And I'm going to end with a little story that has like kind of nothing to do with science really, but I think it's really funny that it happened and I'm so lucky that I survived. And I'm going to tell it because I kind of want to be a planetary scientist when I grew up, and this experience is a little bit of like part of why. Okay, so basically, I went on a day trip to the Big Island by myself because I couldn't find anyone to go with me, and I had so much fun there, and I wanted to hike to the caldera floor of Kilauea so bad. And so I went on the hike even though a flash flood had already started. And there were only 10 people on the hike as opposed to the usual 60 or more because of the weather. And by the time we got down to the bottom, there were only 5. Like, where did the other people go? Did they give up? Did they get abducted by aliens? Like, no one actually knows. But here's a photo of me and John. He's an 80-year-old park ranger, and we're on the floor of Kilauea. And you can actually feel the warmth of the volcano on your feet from the magma that's literally like right underneath you. There was steam rising from the ground. It was so dramatic. It felt like another world because everything everywhere you turn was like totally grayscale except for these small green plants that are growing between the cracks of the volcanic rock. And this photo's on my disposable camera, so you can see the water damage. Like, oh my God, there was so much rain. And we got stuck down there until it stopped raining because we couldn't climb out with all that water rushing down. And yeah, sorry, Mom, I literally got stuck in a volcano. And once I got out, I realized I'd missed the last bus back to the airport. So I tried Uber and Lyft and no one was picking up because the area was so remote. And I walked soaking wet into the lobby of this volcano resort, like think a ski resort, but volcano, and asked if they could connect me with a taxi. And they gave me a business card. I called it. No one answered. So I sat really defeated by the fireplace trying to dry my socks and shoes in the fire. And I almost hitchhiked with this Canadian family until the taxi driver like called me back an hour later. Said he could arrive in 45 minutes, and I was so happy. He had to stop for gas. So I got out and got a snack, but he asked if I wanted to get dinner instead, and I said okay. So we stood outside to listen to these like random distant worship drums, and then we drove off to Dwayne Johnson's favorite diner, got pancakes for dinner, and I went to the airport so wet that my entire body set off the millimeter wave detector, but I made it back to Honolulu in one piece. Anyway, shoot for the stars and follow your dreams because you might end up being rescued from a volcano just in time for pancake dinner.
Yay!
Socials. Thanks so much for listening. I really appreciate it.
Yay!
That was
Yay, yay,
amazing.
yay. Let me hide our logo so we can get your full Instagram there. Wow! 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 Wow!
Wow.
I'm in. The talk was great. The little slice of life of a conference in Hawaii, also amazing.
That was amazing.
I'm-
We were
I'm-
also at that conference.
We were Afra, we don't tell them that. We gotta. Mari, that was such a great story, Mari. That's such a unique story. That's so cool. I mean, we definitely didn't get stuck in a volcano. So
No, I wish, honestly.
but we're also, stretching some time for folks to put in questions in the comments. If they have any, either about the semi-traumatic experience of the volcano and conference, or in general about the awesome machining and construction of a science caliber instrument. There's 2 questions that we fielded almost immediately, which were, back when you showed the bodyworks, I think, or you said the drawing that you did of the of either, was it Mini Chaz or some other, the optical,
Microchaz, yeah.
Micro-
yeah, Micro Chaz. Everybody was asking if you could go back to that slide, please.
Sure.
Robert here was asking, was that Windows 2000?
Oh my god.
And Emma was also thought it was MS DOS. Or was MS
Not
DOS maybe something
actually.
else?
No, that was just part of like the fun little like PowerPoint theme. I actually did this in like a modern operating system in SolidWorks. Okay, so this is like a whole little predicament that I dealt with. It was like SolidWorks 2019 doesn't work in version SolidWorks 2020, and you have to do all these like weird file conversions. But essentially, this is like super modern, and I just put it in Windows 98 for nostalgia and fluff reasons.
I mean, I guess there's a question there in that, like, is all of the technology that you're using to construct this cutting edge instrument modern day, or or sometimes you're like, wow, this is the same piece of machinery that folks were using ages ago? Like, what I have
I'm
no
so
concept.
glad you asked. A lot of the times it is modern like this, although, you know, I'm being a little deceptive by putting it in the little Windows 98 background, but sometimes it is really archaic and like kind of hard to deal with. We have this piece of equipment called the ferro arm that we use for precise measurements on our optic relay, and the software I think is from like 95, and we're using this like really old computer that only connects to the internet with like an Ethernet cable. We have this other like designated floppy disk computer for like one of our softwares that's like only available on floppy disk. So, you know, it's like kind of a mix of like old and new, which I think is really cool.
Nice. That's
That's
great.
very ghostly in a way.
Absolutely.
Way to bring it back to theme there, Afra. Nice. Cool. So I guess you mentioned this trip to Hawaii. Have you also but the instrument lives in Kitt Peak in Arizona? Were you able to observe out there, or like what kind of conditions is this instrument now? And was it like emotional to see it to travel off on its own? Was it like leaving home?
Yeah, I mean, it was absolutely emotional, like super exciting. And this again is like a bit of a sore subject. I was taking Professor Shminovich's class, Observational Astronomy, and a bunch of us from the lab were going to stay after the class trip and do some Chaz data runs. And then, of course, we all got sent home because of the pandemic, and I still haven't actually like been out to see Chaz on the telescope in Arizona, unfortunately, but hopefully one day I'll get to live out this dream of seeing Chaz do its thing on the telescope.
Nice. I guess since Afra was humble bragging about Hawaii, I've been to Kitt Peak, and it's wonderful. So I've seen that telescope that Chaz is on. It's a wonderful place. I'm sure it's very happy being there. Cool. Well, we have time for a couple more questions if anybody wants to throw them into the chat. But otherwise, I mean, Afra and I can keep asking you questions as we go. Afra, do you have anything you want to ask?
I actually wanted to point out Albert. He said that you should pitch how I became a volcanologist to Hollywood. And I think you should. I think you should pitch this story.
Yeah, I think that's such a good idea. Thank you, Albert. I think I will.
I also wanted to ask, like, you've been talking a lot, like some of our audience may not really be in astro, and you've been talking about kind of the differentiation between astro, planetary science, and I would love to hear more about your own personal, why you're drifting to planetary science and what that means, really.
Ooh, yeah, that's a really good question. So I was always like really interested in space, but also interested in building things. And I kind of always wanted to do both at the same time, but didn't really know how. I, by chance, sort of ended up majoring in mechanical engineering in college. And Professor Shminovich kind of pointed out to me that, you know, it is a good point that if you're a person like me who wants to focus on the designing and implementation of scientific instruments, there isn't really like a clear-cut path of what you should study in undergrad and grad school, which is like really interesting. I think my mechanical engineering background gave me really good perspective on, again, like just what it takes to put a machine together. But at the same time, I'm really grateful for having been a part of the Blue Shift community at Columbia that really pushed me to further pursue my interest in the natural sciences and, like ask myself the questions, take the classes, do the research, which was super fun. And I took a class my senior year called Geochemistry of a Habitable Planet, which really sparked my interest. And again, like very similar to what Gabby was talking about, but even more like focused on the solar system and even planet Earth itself, with instruments and what they can do with like analog studies here on Earth, collecting samples and data and like going on little like Earth missions to sort of predict and simulate what we might expect to find in other areas of the solar system, and figuring out what this information can teach us about the history of our own planet and where we're headed now in terms of climate change and other things. I really appreciate how interdisciplinary the field of planetary science is, and I think that's a lot of what draws me to it.
Thank you. Yeah,
That's great.
That was a great answer. Yeah.
Yeah, we've got interdisciplinary with planetary science, interdisciplinary with astrobiology. It's a common theme. Oh, also spooky. We're spooky today.
And
So don't forget spooky. Good.
I think we're learning that knowledge is from everywhere and interdisciplinary.
And scary as well.
And it's scary. It's
Good.
scary to learn.
Well, we're a little bit over time at this point, so we're going to have to keep moving. But thank you so much, Mari, for an amazing talk. Please throw out some claps or chat in the chat. And thank you so much again, Mari, for giving that great talk.
Thank you.
Cool. So we are going to remove Mari's slides. Mari, we'll see you back in 1 second for goodbyes. But Afra and I are going to close out the show right now by talking through the game.
We're going to unmask our
We're going to unmask everything. Exactly. So let's add this back. Can we go to the top of this real quick? Because we got to run through. We're Astro on Tap. We're trying to do these shows once a month. We're hoping to be back in person very, very soon. As soon as we get more information about that, we'll share it with you all. But thank you very much for coming out to this virtual event. Who are our presenters tonight, Afra?
They were Gabriella, Suissa, and Marisa Murillo. You can get in touch with them through our various social media channels. I'm sure they would love to hear from you if you have more questions. And if not, then I don't know.
Please send good, thankful energies for them agreeing to give a talk after the end of their long days and so on. So thank you so much for that.
Thank you so much to our presenters.
Yes.
And thank you for all the fear and joy that you brought to our talk.
Fear and joy at Astronomy on Tap. Good. Let's start wrapping this up. The game. Thank you so much for everybody who filled out the game. I can share that most of you got it completely right. Clearly, it wasn't too much of a challenge. All of you all knew what you're doing. Number one, the pirate was Saturn. It was an infrared light, so I thought maybe I was going to trick some of you, but no. You all saw through it pretty easily.
You got it.
Easy. Number two, the pillars of creation. As the minions.
As the minions.
I thought I was pretty proud of that.
I liked it. I really did.
The witch was actually the Crab Nebula.
That was a tricky one. This
is a slightly different colored version of it. Maybe it is all probably false color anyway, but still, there you go. Number four, the shark. In the shark's mouth was Hubble Ultra Deep Field. Sometimes I'm used to seeing it like with the WIFKey camera signature where there's that little like bit taken out of the top. Anyway, yes, everybody got this one right, I think, actually. So great. I don't want to say I was getting tired of doing it, but honestly, I thought it was pretty inspired to have the horsehead mask be the horsehead nebula.
Mark, I think this is my favorite one by
I'm
far.
pretty pleased with it too. Honestly, it doesn't look like a horse head on the right. I
Not
forget.
really.
I think it's
No.
meant to be somewhere else, like inside of it. Anyway, and then the last one was Mars as Mars.
Oh, okay. I did not understand this one.
Yeah, well, it's this wonderful child's costume, this DIY Mars, and I thought 6. Why not do 6 instead of 5? But again, was another freebie, so I may as well have just done 1 or 2 at this point. Thank you, everybody who participated in the quiz. There were so many of you who were winners that I'm just going to put all your names up on screen at once. We'll send you an email. If you gave us an email to send to, trying to send you something of some kind. We actually have a bunch of those. Gabby was talking about those exoplanet posters, the newer ones. We actually have the originals from the first run of those that we could probably send out to folks. So we'll be in touch in case you want those and where we can send them to. So congratulations to all those folks who completed the game. Are there any more slides to this, or are we done?
There is one slide, the
Oh.
costume.
I haven't seen this.
Oh. And the winner is this is the end.
Oh, that's it. Did we get any submissions for the Astro costume?
No, I do not think so.
Okay, great. Then forget about it. That's the end. Great. Thanks, everybody. Good.
The winner's mark for
Hey, I did it. Yes.
the radio telescope.
Yes. I can take it off then. Woohoo. Okay, great. Well then,
Perfect.
now that I'm free of that terrible costume, let's bring on our presenters one more time. And thank you all for a wonderful evening. Thanks again, Gabby. Thanks again, Mari. Welcome, Afra, to the Astronomy on Tap New York City hosting family. And thank you, everybody, for joining the show.
Thank you, everyone.
Goodbye, and we'll see you all soon. And ending.